Hey everyone, welcome back to Nullvoid. Today we're solving another Leetcode problem called clone graph. It's a medium level difficulty problem, so let's get into it. Let's take a look at the problem description. So we are given a node here, a class node here, which is having int value. That's the value of that node and a list of neighbors. So it is having few neighbors that are connected to it. So just like a normal graph that we create in Java. So let me walk you through the class that we'll be using here. So we have this class node. It's having a int value and list of node. Those are the neighbors of this particular node, and the question says that we have to make a deep copy of this entire graph. So if I have to give you an example, then in example 1, this was our original graph 1 2 3 4. Then we have to make a deep copy of the same graph, and this should look exactly like this. So our input is, so for we are getting an array of array where the index plus 1 to be precise represent the value of that node. So at index 0 we have neighbors 2 comma 4 and the value would be index plus 1. So as we see at index 0 the value is index plus 1, that is 1, 0 plus 1, and it is having neighbors as 2 comma 4. Then the second node will have 1 comma 3 as neighbor. As you can see, 1 comma 3 are its neighbor. Then the third node is having 2 comma 4 as neighbors, and the last node is having 1 comma 3 as neighbors. So that makes sense. We have to return the exact copy of this node, and keep in mind we have to return the deep copy of this node, not shallow copy. So how we will do this? One other thing is, though the input looks like this, that we are getting an adjacency list and we need to return the similar adjacency list but for the clone graph that we have created. But in reality, like in the problem, we'll be getting a node as input to our problem. To basically in our method we'll be getting one of the nodes from this graph as input, and we need to return the cloned version of that node, which will take us to the entire graph. So what I mean by that is, let's go to our drawing board. Yep. Let's say we have this graph where 1 is connected to 2, 3, 3 is connected to 1, 2, 2 is connected to 1, 3, and then 4 and 3 are connected. So, and we have this method called clone graph where we are passing one of the nodes. So, for this example, let's say we are passing the very first node with value 1. So, the first node is having value 2 and 3. So, we can solve this problem using recursion. So, recursion will help us here. So, we got node 1. What we will do is we'll create a copy of the node that we are getting in our method. So we got node 1, we created a copy of it. Now what we need to do is we need to check what are the neighbors of my original node. So 2 and 3 are neighbors of my original node. My new clone node should also have those neighbors. So what we can do is we can use our clone graph method and pass the neighbors that we got from the original node here to it, and then it will return us a clone node, and we can add it as a neighbor of our clone node. So what I mean by that is, so clone graph node 1 will return us the cloned version of node 1, right? And clone graph node 2 will return us the cloned version of node 2. So what we did was we called this method with node 1, and we created a clone node 1. Now we need to add the neighbor of this clone node 1. So we traverse through the neighbor of original node 1. So for, and we'll call this method with those neighbors. So very first call, we will go to node 2 and call the clone graph method. So when we go to clone graph method with node 2, it will create a new clone node with value as 2, and then it will try to do the same thing here. Go to the neighbors of original node 2 and try to get the cloned version of them. So the neighbor of node 2 are 1 and 3. So we what we will do is we again try to call clone graph method with value node 1. But here is the problem: we have already created node 1 in our earlier recursive call, so we do not want to create it again. So what we can do is, in our memory we can maybe create a map with key as the integer value and the value as the node that we have created. So we'll see if we have already created this node. If we have created it, then just take it from the map. If we have not created it, then just create it. So when we call this method for node 2, so let me try to draw some things here. So the very first call will look like this and this. And let's say we have our map here, and in our map we have 1 comma node 1. I'll call it C node 1. C node 1 is clone node 1. So we have this in our map. So when we call it for node 2, it will make a call back to node 1, and we see it's already there in the map. So we'll return from the map. And also at the moment it has created 2 comma node 2, C node 2. I'm not good at drawing this. Yep. So now it will make the same call for node 3. So it will do this. We see node 3 is not present, so let's just create it. Uh, so it will come here and it will create C comma uh, cn3. Let me type this because I do not have space here. So it created this. Now for node 3, it will check what are all the neighbors. So its neighbor is 1 and 2. So it will it will go to node 1. So it will call the clone graph method with node 1. It's already present there in the map. It will just return it. Then it will do the same thing for node 2. Node 2 is already also there, so it will just return back from the map. But for node 4, it's a new node, so it will create a new node. And I think I can type it out instead of drawing it, maybe. Let me check that later. So yes, we created node 4 in our map. Like, we have created a new node for node 4, a new clone node for our node 4. And now we have to make calls for the neighbor of node 4. The only neighbor of node 4 is node 3. So let me just draw it out. It will make this call, but node 3 is already there in the map, so we will just return it. So in the end, when this recursion will come back, it will come back to our clone node 1, where we have populated all the node in the graph and we have made all the necessary connections. So we can just return clone node 1, and that would be our answer. So that's how you solve it. Let me just go to the code, walk you through the code. So let's go here and I'll paste the code here. So I've created this map where I'll be storing the integer value, that is the value of the node, and the pointer to the node, and the object of the node, to be specific. So we have this method, and what we would do is, whatever the node we got, we will just create our own method where we will do this processing. So this original method will act as a shell, and we have our own method where we will do our all the work. So we have this clone method. It also takes just the node, and here it will check if the value of node is null. In case the value of node is null, we can just return null. So that's a basic check. Otherwise, if the map is having the node, then just return the node, exactly what we were doing earlier. So in case it is not, in case it is present, just return it. In case it is not present, create the new node, create a clone of the new node. So we will create a new node with value of the original node. So we'll get a clone node. So we are using one this constructor here, and the neighbors will get initialized as an empty list. So now the next task is to get clone the neighbor of our original node. So before doing that, we need to put this node in our map, so that if my neighbor calls me again, calls the clone method again with the value same as me, then in that case I do not do the, like, I do not get stuck in that loop. I can just check in the map. So we need to put this in the map. The next thing we will do is that we will go through all the neighbors of our original node, and we will call the clone method with the neighbor value. So this clone neighbor method will return us the cloned version of the original neighbor node, and we can just add it to the neighbors of our current clone node. And in the end, we can just return our clone node, and that's good enough for us. So let's try to run it. Yep, that works. Let's submit it. Yep. So that is how you solve this clone graph problem. It's a fairly simple problem. If you understand how these objects are working, how recursion works, then it's fairly simple. If not, then this is a good practice to learn those things. So that's how you solve clone graph on Leetcode. If you found this helpful, then leave a like, share it with your friends, subscribe to my YouTube channel. And if you have any doubt in this problem, or if you want me to solve any other coding problem, you can comment that below and I can take a look. I think that's all from my side for this time. I'll see you next time.